Hello and welcome back to Theoretically Practical. This week we're not working on the Defender. There'll be an update on the status at the end. Essentially, I'm waiting on like a few $2 plastic clips before I can put the clutch together. Oh well, you know, they were back ordered for a couple weeks. Kind of everything is for everything right now. So instead, I'm going to be doing a follow-up to my Tig It to the Limit video because I feel bad that I don't know, looking at some of the responses, I feel like it was clickbaity. It wasn't intended to be. I was just making a funny name. And apparently a lot of people agreed to me. So this will probably be like Tig It to the Limit 2, the one where we actually weld. So we're going to be doing a video on my Lincoln Dialarc 250 HF. And I'm just going to show you what processes it can do and how to set the machine up for those. And that's about it. It's not going to be too in-depth, but I really like this machine, and it's been really good to me. So, we will take a look at what we can do. So, we're doing this outside because it's a beautiful day. So, assuming you got your machine right, wow, I am right in the sun. These are all the bits and bobs you'll have to do your processes. So you should have your TIG torch. Interesting enough, this says a Dialarc HW17 on it, but there's supposed to be a plastic cap there and some other stuff, and I ordered new ones, but they do not fit. I think I'll be replacing this torch, but the replacement's almost $300, and this works, so it's hard to justify at this moment. You got your ground strap right there. You do want to make sure that's in good shape. This one's fine. I haven't had any issues with it anyways. If you're lucky, you got a stick stinger, which we'll be showing you how to stick weld with it. And you should have gotten a pedal. The pedal is a Miller RFC 23AG. I put a little... Oh, weird. I put a little push rod in it to make it remote active, which... It worked, but the high frequency start does terrible things to that electronics, so I gotta rethink that situation. But that's fine. The only thing I would say is if you did get a machine and you have one of these holes here will open right up, and the pedal will get floppy and it may not shut off. So what I did, and you can just see it there, is I put bronze bushings in here, and then I cut little pieces of bronze bushing and actually soldered them to the inner one. So now my foot pedal has no wiggle to it, which has actually made welding with this a lot better. So I know these units are hard to come by, and if you were looking at a machine that didn't have one of these pedals with it, I'd think awful hard about it. I think they're a couple $300 depending on where you can find them from. So we're gonna start with stick welding because it's the most basic setup. So we'll go over the front of the machine. I'll move everything out of the way we don't need. We're just gonna be stick welding on this big chunk of steel right here. So, all right. So you got your machine, you got your bottle of gas. Well, if you're stick welding, first thing I opened up earlier today, yeah, it doesn't need to be on for that. You'll just be wasting gas. So you got your high frequency, you're gonna want that off. Remote contactor will be off. Remote amperage will be off. I have no idea what to set. I'm using a 1/8 inch E6011 because that's what my hardware store sold. I will say something about stick is I opened these like 6 months ago. At some point they will go bad because I'm not storing them in an airtight container. You really should store them airtight. You can bake them in an oven. Don't bake them in the oven in your house. Your significant other will be unhappy with the smell, I am sure. So anyways, I mean, it's 16 bucks for the box. They're pretty cheap. They work really well. These are basically your weld anything steel that's junky and crappy in any position rod. They're just a good generic rod. So yeah, I think it's reverse polarity. I have to double check that. I'm gonna double check that. All right, so we have the machine set up for stick. We have DC electrode positive. We're in the 40 to 190. We're at 70%, which means we're probably at the high end for that rod, but that's fine. We have our amperage control off. We have our remote contactor off. We have our high frequency off. This means nothing because it's a post-flow time. The tank is off, and I'm not going to turn it on because it'll start arcing right now. So I'll just set this on the ground, and we turn on. The fan runs continuously on this unit, and it's very loud, but that's fine. So, whoop, there we go. One more thing. This is not a how to weld video. This is just how to set your machine up for the various processes that it can do, and how I felt about having the machine. First video, a lot of people were like, well, how do you like the machine? And I think it's great. So, I mean, if I only had if I could only have one welder in my shop, that would not be a bad choice at all. You do need so the manual will say you need 78 amps at full bore on this so you need like an 80 amp breaker circuit. I've sized the wire for that circuit, but the sub panel in my garage is only 60 amps, so I actually put the welder on a 50 amp breaker, and I've done a lot of stuff with it, and I have yet to pop the 50 amp breaker. So that's kind of going to be my sign that I need to upgrade when I start popping that and I can't do anything about it. So just so you know, you can put less power to a welder than it requires. It just limits you a little bit. But I've turned this thing almost all the way up and really hadn't seen a sign of issues like that, of popping the circuit breaker. So, but just forewarned is forearmed. Also, you know, I'm just doing quick demonstrations, so I've got no gloves and no proper clothing on. That's a stupid way to do it, and I'll probably burn myself and get some nice UV burns too. Don't be stupid like me. You know, I've got sleeves over there, but it's kind of warm out and I'm lazy. So cool. All right, so to start your arc, you just give it a tap and then you pull back a little bit. It's hard to explain and I'm not great at it. So I'll do a little stick weld here. I'll show you how awful a stick weld can look, and we'll move on to the next process. Oh geez, I couldn't see for crap. Okay, so that weld there is the one I just did. I won't touch it. Looks like a crappy old ugly weld, but that's kind of what the stick is for. Is when you got two, you know, my buddy had a big old trailer, it was all rusted up, you know, and we wanted to put pockets on the sides so you could put stake sides on it and overload it basically. And that's what I used to put it on, and it did a good job of it. Again, I haven't touched the stick weld function of this in 6 months. I just like to have it. You may use AC for certain applications. I mean, read your rod, use the Miller calculator, but that's essentially how you set up the stick weld for this. So we're gonna switch to TIG next, and we're gonna start with aluminum, and then we're gonna go to stainless, mild steel, and brazing rod, because if you have all those settings, you can weld any damn thing you need to, pretty much. Okay, so now we're gonna set up for aluminum welding. So, basically every setting needs to be changed because it's all wrong. First, you're gonna want your polarity on AC. I think for this settings, my settings are close enough. You can look up your amperage settings. For demonstration, it doesn't really matter. Remote amperage is on, remote contactor is on, and your high frequency is not on start, but on continuous. That's very important. And then your post-flow time should be set somewhere appropriate for your material. In the case of this, I'm gonna go for 2.5 seconds. That seems right to me. And then you want your gas on, and oh yeah, if I flick it on for a second, you can see that I'm running just under 20 CFM. Oh, sorry, CFH, cubic feet per hour, not cubic feet per minute. Anyways, yeah, this tank would not would last only 3 minutes at 20 CFM. It's 20 CFH. You know, somewhere between the 15 and 20 range is good. We're gonna have some problems because I'm outside because it's a beautiful day and I want to be outside, and it's a little bit windy, which is it just kills it. So anyways, the welder's all set up. I'm gonna turn it on, get the camera set up, and show you a little bit about aluminum welding. Okay, so we're ready to set up for aluminum welding. I will say I use a 2% lanthanated tungsten electrode. It works for steel, it works for aluminum, works for everything, rather than having to have, you know, typically I would use a 2% thoriated for steel and a pure tungsten for aluminum, but the welder at work suggested I try this, and it works well. The other thing you can do is ball up the end, but again, we're not getting into practice so much, just as how to do this machine. I will show you one thing though. I got this piece of aluminum here. It's not particularly dirty or anything, but you see I got a brush. You're gonna want a stainless steel brush, and I'll show you why right now. So let's say I got this piece of aluminum. It looks pretty clean. If it was a piece of steel, I'd just go to town on it, but it's not. So I'm gonna try to weld it without cleaning this off first, just to show you guys. So, it kind of penetrated, but there's just this skin, and you can see all the burning material there and all the junk and dirt and filth that's trying to come off the surface of the material. Aluminum is very reactive. It's like, you know, this is all aluminum rust essentially. So the surface will become corroded almost instantly. So if I take the spot here and I really brush the heck out of it, and you can see that it's pretty well cleaned off now. And again, you don't want to use this for anything else because you'll contaminate the brush, and it needs to be a stainless steel brush. So now I'm going to try to lay a little bead on that, and it's going to go, well, it won't go worse. Alright, so it's definitely a little windy that isn't helping me, and I snapped off way too quick at the end. You should slowly let go and that'll keep it cleaner. But you can see I got this nice aluminum weld, not through penetration or anything, but it's penetrated pretty good, and well, which one of those would you rather make? That acceptable weld, again, I think my amperage is a little bit low, or this just messy garbage, because it just skins over and you can't, doesn't work. So anyways, that's it for aluminum. We're going to set up for the last three processes, which are all going to be the same settings but different, just different materials. So okay, so we did not touch our regulator. That amount of regulation for that size torch is going to be what you want most of the time anyhow. So the big important thing is you want your polarity straight, DCE negative. Okay, I'm just going to turn it up a little because, well, actually, aluminum uses a lot more amperage than steel or anything else does. So we're going to leave it at these two settings. We're going to leave remote amperage on, remote contactor on, and high frequency to start. I can't tell you how glad I am not to have more dials than this because I think it would be too much for me. So anyways, we're going to go back and we're going to do, it's all going to be on a piece of mild steel. We're going to do a line of stainless, we're going to do a line of bronze, and we're going to do a line of mild steel. So let's get to it. All right, so we're going to start off with a, actually, we're going to start off, that's all right. It's fine for the purpose. Typically, I'd grind the tip clean in between each one if I was doing anything other than a demonstration. And every time you dip, you should grind your tip, and I'm not very good about that. So we're going to start with mild steel. This is just ER70S2, and it's just like copper-coated steel. This is 3/32. I'd prefer 16th, but I'm out of it right now. So we'll go with this. Well, that's the weld. It's not beautiful. I think I needed more filler rod. Again, with the 1/8 inch rod, it's in this material being thinner than 1/8 of an inch, it really is quite tricky to weld it well. Yeah, you guys won't be able to see down the tube, but the weld went the other way, basically. I was kind of melting through a little bit. But, and I snapped it off at the end, which is what gives that crater. But it does it. It does it well, sometimes. So the next thing is I got the stainless steel rod. This is 3/16 stainless. If you're gonna have just one stainless rod for all stainless purposes, this is suggested to me by those who know as the one to have. So we'll do a little stripe right there of it. Well, it looks basically the same. I overheated at the end. That was about to drop through. That's why I shut it off. It will be discolored. You have to like basically polish it up to get it back to stainless steel status. One other thing, if you're welding stainless steel, it will warp. If you're welding stainless to stainless, it will warp the hell out of everything. Stainless moves a lot with heat, so you need to be aware of that, and sometimes you can pre-stress it against it, but you should be aware of that anyways. But it's nice if, like, you know, if you got a stainless steel ladle in the kitchen and the handle breaks off because it's got a couple of tack welds, well, you can bring it out in the garage and slap that on, and away you go. So, finally, this is a silicon bronze rod. It's not coated with anything. I use it when I don't know what type of material I'm welding, especially if it's really junky material. This will weld almost anything together. So we'll give this a shot. All right, so that's the silicon bronze right there. Because it's silicon bronze, the lower melting point, I put a lot less heat into this bar and it welded a lot better. Silicon bronze is really easy to weld with, but it's great for small repairs or really delicate materials or stuff that you don't really know what it is. Will stick together with that most of the time. And actually I have one more thing to do, and that'll actually be silver brazing solder. This is technically a brazing, so this is definitely technically brazing what I did there. The nice thing about doing a TIG braze versus a torch braze, you don't need to use any flux, you just have to have the material clean in it, and it does a great job of it. So this is silver bearing solder. I think it's 20% silver. You can't solder it with a regular soldering gun. You're definitely gonna need a torch. But it's great when you're trying to repair. I used this when I repaired that chiller coil for, ironically, a TIG welder. Again, it's good in a lot of those situations because you don't have to get it quite so hot, so you don't have to get the parent material quite so hot. So we'll do another little bit there, and that should be about it. And the reason why I'm using a piece this small is because this stuff is kind of pricey. And you can see right there, it's got sort of a coppery color to it, but it does a good job at fixing stuff. Again, it's nice to have around. I used it to fix the radiator on my 52 Buick because I dropped the bottom of the radiator on a jack stand and poked a hole in it. Did this, worked great. The gas tank on that vehicle as well was in really good shape, except where someone had lifted the whole thing up with a giant forklift and put a little crinkle in it that had a little pinhole in it. And after very carefully flushing out all the fuel and filling it up with, purging it with gas and all sorts of stuff, I think I just waited like 8 months for it to just basically not have any fuel in it with it open. I used a bit of silver solder on that and it worked fabulously as well. That's been holding for 3 or 4 years now. So anyways, so that's pretty much everything you can do with a Miller Dialarc 250 HF TIG welder. There are a lot of varieties and variants of this, so I'll just talk about them pretty quickly. One, if it doesn't have the high frequency, walk away. The high frequency start or lift start or some sort of start for welding that isn't scratch start. You just, I don't know. You can scratch start TIG. You can do a better job than I can do, for sure. But high frequency is where it's at. My buddy recently picked up a unit. I paid $600 for this unit with all the cables. I had to buy the gas regulator. That was like 25 bucks. That's about it. It's been a beautiful machine. Yeah, so I've encouraged a lot of my buddies. Another one of my buddies picked up a Miller 330 amp synchro wave, and I am, for like 800 bucks, I am so jealous of him because that's a really nice machine. The only thing is, if you're not going to be doing a lot of aluminum, the synchro wave doesn't buy you anything. In fact, it's kind of funny. The guy that I bought this welder from, I go to his shop. He's got it all on a cherry picker. We put it on the trailer. I'm just talking to him because, you know, he had this cool old Mini Cooper that he was working on that I love those old Minis. And so I drooled on that for a while and was talking to him about it. I said, geez, you know, so why'd you get rid of this machine? He's like, well, I heard about the synchro wave and I had to upgrade. I just had to have it. And I'm looking around saying, oh, so you do some aluminum welding too. It just looks like you do steel in here. He's like, oh, no, I never weld aluminum. I said, well, I hate to be the guy that tells you this once you've already loaded the other one up. But, you know, synchro wave only applies to the waveform while you're welding aluminum. And he goes, son of a bitch, I wish someone had told me that a while ago. He was cool about it. It was, you know, I paid him what he was asking for anyways, and he already had the other welder installed. So, you know, there was no hurt feelings. But I didn't want to let someone go, not, you know, when I could give him just a little bit of knowledge. Pretty simple. I really do like this machine because if you look at it, if you look at DC, you know, 250 amps, full load amperage on this, you got 40% duty cycle, same thing for AC, And if you go down to 125 volts AC, amps AC, you got 100% duty cycle. So this thing, you know, you can really run it all day long. So it does say that you can go up to 310 amps with it. So I don't know why quite it lets you do that. But anyways, this machine's been a great machine. I have no regrets. It's welded everything I've wanted it to weld, and it's helped me with a lot of little tiny projects. So cannot recommend it highly enough. And anything Old and Miller. I like the transformer welders. You know, you guys have seen my shop. It's not heated, it's not really conditioned, and it gets hot, it gets cold, it gets wet. Things get wet in here from condensation. And a new machine with the new electronics is, it's guaranteed to break within a few years, whereas this is probably gonna last me the rest of my life. And, you know, I'm not really interested in being an uber welder by any means. As long as I can stick the two pieces of metal together that I need to stick together today to my satisfaction, I'm a happy guy. So that's about it. There should be a short update on the Defender and why I haven't been working on it. It's just a matter of parts right now. There was stuff that I didn't know I needed until I needed it. So, and England's it's not a hop, skip, and a jump away. I did order everything from Rovers North, which is up in Vermont. Their customer service has been great, and I've always, you know, their prices are, well, as reasonable as you're going to get. Realistically, it's not much more expensive than me ordering direct from the UK, and it seems like I get the parts a little bit faster through them. So anyways, you know, and when you start ordering from them, they send you this Land Rover catalog, which is a really cool magazine, and but they definitely make good money sending that to me. I'll put it that way. I look through it and I'm like, ooh, I can get some doors. I can get this. I have a problem, okay? And I'm unwilling to get help for it. So, yeah. So that's about it for this week. Tune in next time. Basically, I got to the point here where I've got the you know, whole flywheel mounted up, the clutch all bolted up. I have an alignment tool. I used it. I don't know how well it worked. It's kind of looser than I would like. But before I put the cover on, I realized I was missing. There are 4 bolts right here that attach this bell housing to what's called the ladder frame, which is it kind of goes under. It's an extra piece of like heavy duty aluminum. Actually, I'll show you the old one. It's right here. So this is the ladder frame on a 200 TDI. It goes under the engine, but over the oil pan. So that's the oil pan side, that's the engine side, and that's where those 4 bolts go. And of course, since they were, oh good, I had some oil on the floor too. Of course, because they were, I had to take this off to see how badly Rodney had left the party, which was very badly. And so, of course, since those are the first things I take off, and they're the only socket head cap screws on the whole frickin', or socket head bolts on the whole engine, I, of course, have lost those. But I ordered new ones. They're on back order, so that's part of the reason I can't close it up. I could get them maybe from the hardware store, but they're a weird size and length. They're like M10 by 80 millimeter. And I was already ordering from Rovers North, so I just threw them in the basket. So, that leaves me the rest of the stuff I'm missing. So, I got my throwout bearing here. I did buy a new one of these. This goes right there, and it's the pivot point, and it was really scarred. And I would have let this go, but since there were a few parts I had to have, and it was $50, I kind of said, all right. And also because this is the upgraded version. This is what they do to upgrade. They just slap a plate over it, because apparently where this socket is that ball rides in, it has a tendency to crack and pop through and you lose your clutch. So yeah. So I figured I'd replace them both. I got new ones of these. I was going to reuse these, but they are actually more worn than they look. They just look a little bit polished on the war side, but the bore is kind of worn out. And then there's this little hole in the side of that bracket that is used to clip goes into one of these little saddles in the side of the throwout bearing. And it's a little plastic clip, but I don't have it. And the other little plastic clip I'm missing is to hold... The other little plastic clip I'm missing holds the clutch rod into there, just goes into there. And I don't think that any of these were present when I took the bell housing assembly apart, but anyways, so yeah, so we're not doing that today. It's kind of neat to notice. I'll talk more about this when we get back to it, but it's kind of a neat design made to go underwater, basically.